Hi everyone, I'm Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today I'm going to tell you regularizing deep network in neural networks. Here introducing the concept within the broader context of deep learning and applications. Here emphasize that the model deep increases, overfitting become a critical challenge. Here state the lecture focus on method to improve generalization performance. Here, regularization is not optimal in deep learning, but it is essential for building reliable and scalable models. So, a small recap before we get into this topic. Here, it controls model capacity, it prevents overfitting, and it improves generalization errors. Here, learning objective is modified. Here, loss equal to empirical loss plus logical regularization terms, which is equal to empirical loss divided by regularization term. Here, regularization introduces a bias variance trade-off. It reduces variances, slightly increase bias. Here, the generalization errors is a true performance metric, not training accuracy. And main objective of this is while diagnosing overfitting using learning curves, we must understand the capacity of a data size and also implement regularizing technique in practice. So from this side, we see overfitting may occur. So training error is less than the testing error. We may got a error. We may get it into the second time testing, and then also get error, and then third time testing. So here the root cause is noise of the data. And also, while we collecting the data set, there must be of irrelevant patterns, and there is a chance to data for specific features here. And here, and the mathematical insight is high model complexity, while large hypothesis space, it leads to overfit risk. In emphasize and define part, here overfitting characters like high variance, low accuracy, low bias, and poor robustness. And here the statistical view of model approximation, training, redistribution, but fails on true data distributions. Here overfitting is equal to high variance. Here low training error plus high generalization gap. And the idea of generalization is that is a data level method, model level method, and then training level methods, regularization methods. By these four methods, we get into the types of regularization techniques. While in data level methods, there are data augmentation and it increases the data set size. While in model level methods, we reduce the layers or parameters. And in third training level methods, we must have a yearly stopping or a batch normalization method. And these are the indirect regularization methods. And the main regularization methods are preferred because it allows returning model capacity while controlling overfitting. So in this slide, introduces a regularization as a principal approach to connect with the optimization. Here, regularization modifies the objective function here. See, while starting data normalizing, and we collect the data validation, testing, and then feed into the AI model, and it parallelly connected to the model optimization, and not also with the help of artificial neural network connection. Well, if condition is satisfied, get into the result predictions. If there is a error, then we modify the uh, data set and then denormalizing data and output, and this is the end of the regulation deep network. In regularization, is a technique which is mainly used to reduce overfitting. Here it adds the constraints or penalties to the learning terms such as the absolute error and squared the error, or we have to include the text as a penalty or data as a penalty likewise. And then why regularization is needed? Because deep networks that is have millions of parameters and highly expressive, and the main problem here is parameter redundancy and co adaptation of neurons. And conclusion here is improve stability and robustness, and it prevents extreme parameter value. And the first type is L1 regularization here. As I already told here we add the penalty term of absolute value of weight to the loss function. So here loss function is equal to actual function plus summation of absolute of weight of loss function here. And this is also called as loss or regularization. It stands for least absolute shrinkage and selection operator. And then second type is L2 regularization. It's also called as ridge or Tekhanova regularization. As like previous one, what we did at previous one, we just take a modulus of modulo or absolute value of the error term. As like here, we add squared value of weight to the loss function is the penalty term. And this is mainly used in reduce the magnitude of a weight. It keeps all futures but control their influences, and it produces a smooth and stable model. Here it can work heavily in large weights, and it model avoids relying too much on single features here. And then third one is comparison between the L1 and L2, and then dropout regularization. Here it disable neurons during training. That is nothing but it randomly and intentionally turn off neurons during training. It mainly prevents overfitting, and also it maintain the robustness. It prevents co-adoption of neurons and acts like a training multiple model. Here it acts as each iteration neurons are ignored. Here network learn to perform well with the missing neurons. Unlike in a face recognition system, here dropout ensures the model does not depend only on one feature but learns full face features here. And then one is yearly stopping. So this yearly stopping halts training when validation error starts increasing. While in activation function, it make neurons, that is a weight and parameter as a 0. Here it prevents the model from overlearning noise and stop training the optimal point here. Here it monitor the validation loss and stop training when it begins to rise. This is the knowledge game map of or mind map of regularization technique, and small activity while in a classroom discussion. So small recap of what we did in this slide is our regularization technique. It is the main vital role in deep learning by controlling model complexity and preventing overfitting. As deep neural network contains a large number of parameters, they tend to memorize training data instead of learning meaningful patterns. It has the types of techniques. So each technique has a unique principle. Like L1, it simplifies the model through feature selection, and then L2, it establishes learning by controlling the weighting values, and dropout improves robustness by preventing neuron dependencies, and yearly stopping, it ensures the optimal training duration. Together, these methods helps in building models that can accurate, stable, and capable of generalizing well to unseen data. So overall, regularization ensures that a model learns the underlying pattern of data rather than memorizing it, leading to better real-world performances. Hope you guys understand what is regularization, why we need regularization, what are the types in regularization. Thank you everyone. Thank you all.